So I'm going to be talking about inheritance, the component design pattern, and ways to increase performance. Let's start off by creating a 2D scene, and we'll just call this main. And we'll create a player scene, call it player, and we'll save this as its own scene called player. And we'll give player a sprite. And we'll give player a player script. And we're going to put this all in a folder called player. Okay. Now, first of all, we should put this in a namespace. So we'll just put it in a namespace called player. Let's talk about inheritance. So let's say we had this class called entity, and it extended from, let's say, rigid body 2D. And let's say player extended from entity instead of no 2D. So you can do this, but I would say avoid doing this because now you're making the assumption that every entity in your game is a rigid body 2D. And this is generally not the case because, for example, I like to make my projectiles root node a node 2D, and if I'm making, for example, a crate that doesn't move, you're probably going to want to extend from static body 2D. And so you might make the argument, well, I could just create multiple classes. So I could say moving entity and static entity, or a non-moving entity. And this could extend from static body 2D. So I would say even avoid doing this, because now if you had some really complicated function in moving entity, and let's say you also wanted this function in static entity, you can't really share that code between the classes unless you make a public static utils class and you share common functionality between the two like this. So then I would say avoid doing this. I mean, you can, but I'm going to show you a better way. So the better way is the component design pattern. So we're just going to revert this back to extend from no 2D. And in the player class, player scene, we're going to create nodes for each component. So there's going to be a movement component, and there's going to be a rotation component. And of course, as your game gets more complex, you'll have more components like a health component and so on. But just for this, we're going to have movement and rotation. So we're going to create two scripts. One's called player movement component, and another is called, I'm actually just going to call it player rotation and remove the component suffix because it's kind of a lot to say. And we're just going to attach player movement to movement and player rotation to rotation. And so if we go in the movement script and make sure the script name is actually what the file name is. So first we need to get the root player node, otherwise known as the owner. And to do that, let's just create a player variable. First, we need to be in the correct namespace. And so we could use enter tree or ready. Doesn't really matter. I'm going to use enter tree. This is when the node enters the tree. So we can use get owner player. And just a heads up, if player was local, so it wasn't its own scene, then getOwner would actually get this node 2D here. But since player is its own its own scene, owner is this player node right here. So yeah, and let's keep the root player node having this empty player script, because it's useful later on. You'll find it's useful later on. So that's what getOwner does. And so now let's make this player move. So you might be wondering, should I use the physics process or should I just use the process? And since this isn't, we're just going to be modifying the position directly, we're not doing anything physics related, and I've actually found that the process override is actually more performant to use in the engine than the physics process, strangely enough. We're going to need to get the direction, the input direction. So there's this useful function called getVector, and we're going to use these built-in input actions that are already defined for us. So UI left, UI right, UI up, and UI down. I think I got that backwards. Okay, I think I did that right. And then we can just say player.position plus equals direction times speed. And so we can define speed as an export up here. So private float speed, and we'll set it to 5. And now when we run our game, actually I got the directions mixed up. This should be UI down, and this should be UI up. Yeah, it looks like down is actually up for Godot and up's actually down. So now when we run the game, you should be able to move your player with your arrow keys. And so let's do the rotation real quick. So we'll do the same thing. First we'll put this in the correct namespace. So mygame.player, and we'll override enter tree, and we'll say private player, and player equals getOwner player. And then in the process, because we're not doing anything physics related, we can get the distance between the mouse position and the player. So vector2 distance equals player.position minus player.getGlobal mouse position. And then with this, we can get the angle. So angle equals distance dot angle, and then we can set the rotation, the player's rotation, to be ff.lerp from player.rotation to the angle, and we can give a speed here. And we'll set the speed to 0.05. That should be a good value. So now, hopefully this works. And now as you can see, there's actually a bug here. As you can see, it's kind of resetting the rotation. So to fix that, instead of using maff.lerp, we can use maff.lerp angle. And now you'll see it's fixed. It won't reset its rotation. Very cool. So now this is how you may have seen other people do the component design pattern. But for C#, specifically C#, I found that calling any kind of Godot function, like process, to be very expensive. So the more components we add and the more processes we override, the more it's going to bog down your game. And you won't notice this with just a few nodes, but I actually tested this with 3,000 nodes, and that's when you actually see a noticeable difference. With 3,000 nodes all having their own process function, you'll get something like, I don't know, I think it was around like 20 FPS. But if we were just to use like a centralized root script that handled all of this for us, then we could increase that easily to 300 FPS. So I'm going to show you how to do that. So let's remove these nodes here, and let's go into our player script, and instead of player rotation extending from node, we're going to extend from nothing, and instead we're going to create a constructor that allows us to pass in the player. And so then we can change this. Actually, we can just remove all of that and change this to public void update. And this, we can just leave that for now, I guess. Remove this for now. And then in player movements, we will no longer extend from node. We'll remove all of this. We'll remove that. And we'll create a constructor that accepts player. And we'll change this to public void update double delta. And I know we should actually be multiplying by delta here. So it makes the player's movement uniform no matter what computer you're on. And yeah, so then we can actually remove partial keyword as well. Okay. So in the player script, we can then say private player movement, and private player rotation, and then in player's enter tree function, or we'll use ready just to mix things up. We can say movement equals new movement, player movement, then we pass in the player, and we do the same for rotation. And in the process, we can call their update functions. You might be wondering, well, how do I have my exports? My exports are missing. Well, we could define the exports in player like this and call this movement speed and call this one rotation speed. And then we could pass these values to the constructor, or we could just access them if we made them public properties. And then in movement, you could say player dot movement speed. But the problem with this is you can also, if this was also public, the problem with this is you can also accidentally use rotation speed here. It's highly unlikely that you would do this, but let's make our lives a little bit more difficult and easier at the same time. So we're actually going to create 2 new resource classes. So we're going to call this one player movement config. And it's going to extend from a resource. And we're going to put this in its own file because the resource will not work otherwise. And this needs to use the global class attribute so the engine, Godot engine, can actually see this. And in here we'll just put public float speed. That's all we need. And we'll also create one for rotation. So player rotation config. And this will also be in its own file. And just like the other one, this should use global class. And just like the other one, we'll also put a speed variable in here, and we'll give them some defaults. So 0.05 for rotation and 5 for the movement. And now back in player, instead of doing this, we can say player movement config, and then say movement config, and this actually can be private so the other classes don't see this. And we'll pass the configs to each constructor. So in here we'll say player movement config. And we'll just call it config. And we'll do config.speed. And here we'll do player rotation config and config.speed. And so we can compile this. And I did something wrong. Oh, right, I need to pass the configs. Okay, we'll build this again. And if we go to player, you can see in the inspector on the right, we can assign a movement config and a rotation config. And for some reason, we can't see the speed property. Okay, so I figured out why it wasn't working, and it's just because I forgot to include this export attribute right here. So just make sure your config classes have this for each property. And in the movement, you're also going to want to multiply the speed by 100, just because delta is a really small value. And so if we go back to Godot and we build it, and another thing, I accidentally included the player.cs script here as well, so just make sure it's not there. And so if we run the scene, you'll see we'll be able to move our player around just like before. And if we want to make it faster, we can do that. And if we want to for example, lower the rotation, we can do that as well. And I just have one final tip for you guys, and that's with this get vector. You'll notice that it accepts string names, but we're passing in strings. And so if we pass in a string, every update frame is going to have to convert to a string name, which isn't very performance friendly. So we can actually prevent that by creating a new class, a new static class called input actions. And we can say public static string name UI left equals UI left. And since this is public, I'm going to make it a property, a read-only property, and we'll do the rest for the others. And so we just replace these strings with the string names. Oh, right. And so now we won't be doing the string to string name conversions anymore, and this will speed up your code. And you'll see that we'll be able to run the game just fine. So that's all I wanted to show. I hope you found this useful. If you have any questions, I'll post a link to my Discord in the video description. But yeah, I hope you have a nice day.